In this video, I'd like to talk about a data structure called a queue. Queue, right? A queue data structure is essentially the equivalent of a line of people waiting at the grocery store, a line of cars waiting at the next fast food joint. It stores data in a sequential order, and it has two main operations on it. It has a push operation and it has a pop operation. The push operation adds data. And then the pop operation removes data. And the key is how it adds data and how it removes data. So I have a deck of playing cards right here, and we'll just look at these face up. A queue data structure, because it's sort of like people waiting in line, the longer the data has been inside the data structure, the quicker it's going to be removed from it, right? Or when you add data into it, the order in which you add data is going to be the order in which you get data back, right? Sometimes this is called a first in, first out data structure, right? The first elements to go in are the first elements to go out. So if I were to create a queue data structure just using this deck of cards, I might push the element 7 onto it. Then I'm going to push the element of an ace onto it, then a 6, then the jack, and I'm adding data onto it. I'm pushing data into this queue. I'm going to push more data into this queue. Now, if I were to go and pop data from this queue, what I would do is I would remove the data that has been in there the longest. So when I want to pop something, I want to know who is next in line. Well, 7's been waiting the longest, so next time I call pop, I'm going to get the 7 back into my hand. After that, the next time I call pop, I'm going to get this ace. And then I'll get the 6, and then I'll get the jack, right? The iPad's not liking that. And so I'm going to get the data back out in the order in which it goes in, right? Hence the first in, first out, right? You can think of every single piece of data that's going into this as a sort of waiting in line to see who's next to be processed, or the next element to be removed from the data structure. Now, queues can be implemented using using vectors, or they can be implemented using a contiguous block of memory, or they can be implemented using a linked list data structure. Commonly, because you are adding data onto the end and then you are removing data from the front of this thing, right? You may guess that it's actually better suited for a linked list type data structure, because remember that with like a linked list, as you add data onto the end, adding is almost like it's essentially a constant time. You might need to iterate through the entire linked list, but it's fast. And then removing an element from the front is definitely constant time. And so removing the element from the front, unlike with a vector, you don't need to shift them all. So queues are very commonly implemented using some sort of linked list type data structure. So the big difference here is that there's those two operations, a push operation and a pop operation. A push operation to add data onto the end, a pop operation to take the next element off of the front, right? Whatever's been waiting the longest.